Hello. In this example, we want to use the correct order of operations to evaluate the following. Leave answers as improper fractions if necessary. Okay, so we have negative 2 parentheses 10 over 7 minus 5 over 3, close parentheses, minus 6 minus 1 all over 42. Okay, so again, the order of operations, PEMDAS. Please excuse my dear Aunt Sally or any other crazy expression that you have. Now, notice that we do have a set of parentheses here, but we have an understood set of parentheses here as well. So technically, for this, we actually need to evaluate two different sets of parentheses. So over here, it's actually pretty simple. 6 minus 1 is just 5. So I'm just left with 5 over 42. Over here, we have 10 over 7 minus 5 over 3. Okay, so we need to evaluate that. And to do that, we need a common denominator. And the common denominator between 7 and 3 is 21. Now, 7 times 3 gives us 21. 10 times 3 gives us 30. 3 times 7 gives us 21, so 5 times 7 gives us 35. And at this point, we can now just simplify the parentheses. 30 minus 35 is negative 5, and 21 just stays as 21. Good. So we're left with negative 2 times negative 5 over 21, close parentheses, minus 5 over 42. Excellent. We have no more parentheses. There are no exponents. So now we're just left with multiplication and division, and then addition and subtraction. There is multiplication here, but it's this one right here. Now we have to be very, very, very careful with this. A lot of people get this wrong. A lot of people take the negative 2 and multiply it by negative 5, and then multiply the negative 2 times the 21. We can't do that. That's changing this, or it's technically not changing the fraction. It's just converting that into a fraction with a different denominator. We don't want to do that. We want to actually evaluate this expression. The reason that we can't just multiply both the numerator and the denominator by 2 is because negative 2 isn't negative 2. Negative 2 is technically negative 2 over 1 instead of just negative 2. This is why when we're multiplying like this, you need to remember that integers are fractions. They're just fractions with a denominator of 1. So for this one, the 2 does not share any common factor with either the 1 or 21. Neither does the 5 share anything with the 1 or 21. Therefore, we can just multiply straight across, making this negative 2 times negative 5 is positive 10. And then 1 times 21 is 21. So what we're left with is 10 over 21 minus 5 over 42. Notice that a denominator of 42 is the common denominator here. So now I do need to change this into denominator of 42. 21 times 2 gives us 42. 10 times 2 gives us 20. And we still have our minus 5 there. Good. 20 minus 5 is 15. So we're left with 15 over 42. And they're actually both divisible by 3. And the reason that I know that, to see if something is divisible by 3, just add up all of the digits. 1 plus 5 gives us 6. Is 6 divisible by 3? Yes, it is. How about 4 plus 2? That's 6. Is 42 divisible by, is 6 divisible, is 6 divisible by 3? Yes, it is. So that means that both are divisible by 3, which means I need to divide both the numerator and denominator by 3, which means 15 over 3 is 5. And now 42 divided by 3 is just 14. Use your calculator if you need to there. And there's our answer. 5 over 14. Alrighty. Well, I'll see you in the next video. Have fun.